mass average versus?
For the quiz, not great. 8.
8%?
No, 8 out of 20.
Oh.
Which is still not that much better.
I think you should scrap that one.
It's better than 8%, but
You should scrap that one from the board actually.
and that would be a 40%. So remember, the lowest quiz score does drop. I have a feeling for a lot of us it might be quiz 5. A lot of us, did not do great on that one. Not super awesome. This is 3-5. The 3-5 homework due is due Thursday, because we have time, because there's lots and lots and lots and lots and lots and lots of graphs. Because we're going to be graphing all day and today and all day tomorrow. All the graphs. So many graphs. We're going to be using A, H, K, and B a lot. A, H, and K will 100% be familiar. You use them in Algebra 2 a gazillion times. For everything, we used A, H, and K. B may or may not be new. B is very much like A, but it works on the X's, not on the Y's. So it can do a horizontal stretch or compress or a horizontal reflection over the Y-axis. I gotta fix this. And what we're gonna do is we're gonna be working with the parent functions. So the parent function of our quadratics, that's our x squared. Parent function of the absolute value, that's absolute value of x. The parent function of our cubics, that looks like x to the third. Square roots, we talk about square root of x. Our rational, that's 1 over x. And the step function, or the greatest integer function, it looks really weird. It's like a double bracket. It looks like this. And we will talk about all of these and kind of what they look like over the course of the next couple of days. And I'm going to pass out to you guys 2 sheets. One of which is a page for you guys to fill in of parent functions that you guys can use as a reference if you want it. The other one is some graphs for today. Don't be graphs. All that. As many graphs as you can, and I may wind up passing out more graphs to you depending on how fast we get through things. Okay, so here's parent functions, and then here's graphs for today. The parent functions is just a reference tool for you guys if you want it. I'm never going to collect that. I'm not going to do anything with it, but it's if you struggle to pull up parent functions, it's a good tool for that. Kind of practice it to fill it in. It also gives you the transformation forms, except for it doesn't have the B on it. It is? Oh, wow. There we go. All right. So the parent function thing, you should be able to kind of fill in. Yes, dear. Oh, sorry. I kind of just remembered what the topic was. The parent function page just kind of is to remind you of those things. I think we actually took this from Algebra 2 because it is missing, in fact, where all those B's are. It has A, H, and K on them. For all of those functions, it would be multiplied in front of the X. So A, B, X minus H plus K. Like if this was squared, or if this was square root, or if this was cube, or if this were like rational would be in the same kind of place, but that's kind of the vibe. The B is in front of the X. Just because on these on the library of functions page, it doesn't have B on there anywhere, but just so you guys know where it goes, B times is by the X inside. And we are going to graph using A, B, X, and H repeatedly. Oh, come on, screen. Stop being a jerk. There we go. And we are going to do as many graphs as we can fit in today. I have 9 in my slideshow. I don't know that we'll get to 9, but we're going to do at least some of all the forms I went to today. I know, I only gave you 6. If we get to 9, great, and I will pass out more. I have a gazillion more graphs. But I was going to be realistic and say, let's just start with X. So busy. But how was yours? Well, I had to get all of my coursework done, which took all of Saturday, because I have to get next week's done too, because I'm going camping next weekend, which means I won't have internet, so I had to do all of my college work a week ahead. Because I'm in grad school right now. Yay! So between the grading of the quizzes and all my algebra tests and my prime tests and all my coursework, I literally worked all day Saturday.
What are you going to grad school?
I'm getting a master's in mathematics for teachers. And it's because of this course. I have to either have one or be working on one. So I am in a level 600 algebra course, which is kicking my butt. Like, you should look at my homework. It doesn't look like math. Sure don't. There's no numbers. It's bad. Like you think we have lots of letters. Oh, it's bad. All right. To be the math teacher, you don't have to do like this part level. Like I had to do Calc 3, which was fine. Like, that's doable. All right. So we're going to start with a very familiar one so we can remember these things. We have here f of x equals 2 times parentheses x minus 3 squared. What shape is this? What kind of function is it? It's a parabola. This is a quadratic. Yes, Oh, yeah, I can get you more scissors. I was going to say, I don't know why, but like my first and second periods always steal out of that box. So this is a quadratic. That means we're going to do our transformations from the parent function of x squared. Yeah. So we're going to use our parent table where we have our -2, -1, 0, 1, and 2. I grabbed them and then I promptly threw them at the floor near you. With our parent function of 4, 1, 0, 1, and 4. Hopefully that's vaguely familiar. What we're going to do to get our transformed function, we take our y times a plus k. And we have x times b plus h. This is the table we are going to use for everything for all of these pieces.
Those are some like SpongeBob shoes.
They're very squeaky. And they also leave like scuff marks all over the place. So. So you can always time the path I wear with these, but like I'm gonna So, we need to find our values. What is A? What is B? 1. B is multiplied in front of our X inside whatever our grouping is, the parentheses usually. What is our H? Positive 3.
So,
It's the opposite. H opposite. I was gonna say I've heard the haha they tricked you, and I've heard the opposite because you hopping. H always has the opposite sign of your equation. Let's lose the conversations, please. What's our K? 0. There's nothing added on the end. So I'm taking my X's from this column times my B plus H. So in this case, we're going times 1 plus 3, which is going to give us 1, yeah, my thicker pen, 1, 2, 3, 4, and 5, right? Because I took negative 2 times 1, negative 2, plus 3. Negative 1 times 1 plus 3. Then we're going to take our y values from our parent table times A, so in this case times 2 plus 0. So 4 times 2 gives us 8, plus 0 is 8. 1 times 2 is 2, plus 0 is 2. 3 times 0 is 0. Sorry, my brain just stopped there. 0 times 1 is 0, plus 0. Too many zeros, and I started smushing things together. 2 and 8. And then we have these graphs. Then we plot up our points. So how are we on the table? 1, 8, 2, 2, 3, 0, 4, 2, and 5, 8. Something like that. See it?
yeah.
Okay. So this one should be vaguely familiar, but that's the plan for all of them. X times B plus H, Y times A plus K. The faster you can do it, the easier this is going to be, because like we're going to be like literally graphing these for forever. Not for forever, but we're going to start taking these and then making those piecewise functions. Okay. Let's stay in our parabolas for a second and do another one like this. So this is another parabola. This is another x squared. So we're going to use our same parent function as the one we just did. Negative 2, negative 1, 0, 1, 2. Giving us 4, 1, 0, 1, and 4. So being able to come up with your parent table is going to be super duper handy for these. Then when we do our transformed function, x times b plus h, y times a plus k. So we're going to look at our function. We're going to find out what a is, what b is, what h is, and what k is. We're going to find them all. So what is our a value? 1. What is our b? 1/4. What is our h? 0. And what is our k? 3. I recommend writing them all out. It's way easier to think them all at the same time than to try and figure it out in the midst of your table. So this is going to have a different kind of transformation. This has a horizontal compression. And we'll see what that looks like here in just a second. Because we're going to take our x values from our parent table times our b times that 1/4 plus our h. So what is negative 2 times 1/4? Negative 1/2. What is negative 1 times negative 1/4? Negative 1/4. 0 times negative 1/4. 1 times 1/4. And 2 times 1/4. 1/2. So it changed my x values. Then we're going to do our y times a plus k. 4 times 1 plus 3. And then 1 times 1 plus 3. 4. 3. 4. 7. Plot our points, and we'll see what this horizontal compression looks like. So we have negative 1/2, 7, which is right there. Negative 1/4, 4. 0, 3. 1/4, 4. And 1/2, 7. So horizontal compression he's super skinny. The horizontal compression works a whole lot like a vertical stretch. Because all it is that when we have our A compression, our vertical compression, it squishes it this way. Horizontal compression squishes it this way. It's the very same vibe. Okay? So that was our first time using B. Same vibe as A though. How we feeling on our parabolas? We've worked with parabolas for a long time. We should be hopefully okay. That's why I started with our parabolas. Let's see. Let's do this one. So we're going to do an absolute value. So we got f of x equals the absolute value of 1/2 quantity x plus 3. So we have a new parent table this time. I mean, not new, but like new to today. Where we're going to think about our absolute value of x. What x values are we going to use? And what are our y values? What's the absolute value of negative 2? Absolute value negative 1. 0. 1. 2. Boom. Parent table. It is way easier to refigure out the parent table if we get stuck than to try and figure it out in the midst of the mess. Yes, dear. Yes, dear.
So for the last one,
Mm-hmm.
I know -2, -1, 0, and 1 and 2 are like the argument.
Mm-hmm.
And then for the last one, I'm trying to change that.
On this one you're talking?
Yeah, just like
So to do the transformations, so you're talking how do we get these y values or those y values? These ones? So we use our parent function, x squared. Negative 2 squared gave us 4. Okay, so it's always that parent function. So we're going to look at the absolute value. Since it's an absolute value, I know it's going to use my absolute value parent table, which means we do this. Then we're going to do our transformations just like we've done. So we're going to find our A. What's our A value here? 1. Remember, it's outside the function. What's our B? 1/2. What's our H? -3. And what's our K? 0. Okay? Same vibe. X times B plus H and Y times A plus K. So we have our X times our 1/2, so -2 times 1/2 plus -3. -1 times 1/2, -1/2, or -0.5, minus 3. -3.5. I heard somebody say it. Because it's inside our operation, inside the function rule.
So there's outside the absolute value of the A.
Yes. So we're going to take our 0 from our parent table. 0 times 1/2 minus 3. Throw in my stylus. 1 times minus 1/2. Or sorry, 1 times 1/2. 0.5 minus 3. 2, yeah, -2.5. 1/2 minus 3. It's -2.5. All right, 2 times 1/2 minus 3. -2. Watch out for those signs. 1 minus 3. Then we're going to take our y values, y times a. So times 1 plus 0. Are my y values changing at all? No. 2, 1, 0, 1, 2. Don't even have to think it. So we get our points here. -4, 2. -3.5, 1. How did I get? Oh, that's not 6. That's a 0. It's just bad handwriting. That's a 0. I just wrote it really fast. -3, 0. -2.5, 1. And -2, 2. This is the one that we should use rulers on. It's a straight line. I'm so good at straight lines, y'all. I am a fine artiste. Absolute values will always be V's. Yes. Oh my gosh. Y'all need to learn email etiquette. I just got 5 emails with a half thought each from a student. It was like they were clearly thinking and like texting, and it would have been 5 texts, but they all came through as individual emails.
Oh, that's weird.
I don't like that either. Okay, let's do another absolute value. Yeah, let's do this one. Okay. So it's another absolute value. Let's use our parent table for our absolute values. X and Y for the absolute value of X. It's the same parent table from the last one. Yeah, I think it's probably good. We could always, like, I have 3 for each, but I'm like, I feel like 2 gives us the vibe of it. So we're gonna do 1 more type of function today, and then tomorrow we'll do 3 more types of functions. Same kind of vibe. That's what my 6th period calls it too, when they have graphs to cut up and put in a graph. That's why occasionally you come in and there's confetti everywhere, because my Algebra 2 gets these a lot. And they tend to take the scissors and just go to town on any scraps. Yeah. I'll have to go steal some more from the supply cabinet. That's the last one in my box.
Thank you.
Oh, but I have 2 loose ones on my desk. All right. So what is our A value here? -1. What is our B? That is way too many lines there. B is 2. What is H? What is K? 0. Just a couple of little reflections here. I mean, we have several more functions. We've got square roots, we've got rationals.
But like it's just this, right?
Well, yeah,
but
we're
with
gonna
other
take these,
Uh-huh.
and then we're gonna start making the piecewise where we have the walls with these. But it's the same vibe. Same vibe. X times B plus H. Y times A plus K. When in doubt, always think about the yak. That helps you remember which ones to go with which. Yak. X, B, and H don't make a thing. Like, I can't make a phrase for it. But yak. Everything else goes with X. X. You have to on that. Now, like, it's a little phlegmy. Not a language I speak, so I don't know anything with that. All right, so we've got our X times B, so we're going to take my -2 times my +2 to get -4. I don't like that marker, I want that thicker. -1 times 2, 0 times 2, 1 times 2, and 2 times 2. So our X times our B. Our H was 0, so we didn't even have to worry about anything adding on. Yes. Our A is the one that's negative, so that's going to change our Y values. Say it again. The absolute value right there? I don't know what you mean. Yeah.
Why wouldn't it be +4?
Because the negative is outside the absolute value, so that's our A. It's going to go on the Y values. So you're going to it's going to wind up flipping across our Y axis. So we're
The
gonna,
absolute value doesn't do anything?
the absolute value tells us what parent function to use.
That's it?
Pretty much.
It doesn't affect anything else?
All right, so we should get for our Y values -2, -1, 0, -1, -2. Okay. What was that? I just heard the most random sentence fragment waft across the crowd. I was gonna say, there's sometimes when I'm just like, I'm not gonna ask, but I'm just gonna be like, let's have a different thought. Yes, dear. So we had our -2 times +2. -1 times +2. Our x's are all times that b, so they're timesing by this +2. Our y's are timesing by the a, so y times -1. It's just gonna make all these flip their sign. Okay? Trust your tables and just do your work through there. Eventually, we can get to the point where we may not need it and start to notice the patterns, and I'm okay with that. I'm not going to be grading your tables.
You're not?
if it doesn't take, like, if you don't need the table and you can get the graph, great. I'm going to be grading your graph. The table is just an easy way to get your graph. So -2, 1, 0, 0, 2, -1, and 4, -2. Like, in fact, the other DC pre-cal teacher, she's like, I don't use the tables. I have them just learn how to do the transformations in their head. And I'm like, having something to write down makes it so much easier than trying to do it in your head. It's more writing, but I feel like this makes more sense than trying to do it all in here. If you can do it all in here, great, more power to you. I can't. I write it down. If it's a straight line, I highly recommend using a ruler, please, or the edge of your ID, or the edge of your paper, or the edge of your pencil. Something. Okay. One more type of function today. We are going to do some cubics. Cubics, we might not be able to pull up this parent function as quickly. But x's and y's for my cubic function, this is x to the third. X to the third, we can still use our same kind of basic 5 center view. -2, -1, 0, 1, and 2. For my y values, what is -2 cubed? -8. -1 cubed. 0 cubed. 1 cubed. And 2 cubed. 8. So that's our parent function for the cubes. Again, I think that is an easier math to do in our head than having to figure out 1/2 times the opposite of x cubed plus 1. Like, that's a whole lot. X times b plus h, y times a plus k. So what is our a value? 1/2. What is our b value? -1. What is our h value?
0.
What is our k value?
1.
Boom. Put it on the table. So we're going to do our x's times our 1/2. So, chunky marker. I have -1, -1/2. -2 times 1/2. Oh, yes, you're right. Never mind. Totally using the wrong one. I was doing my a. X times, so -2 times -1. +2. +1. 0, -1, -2. Then we're going to do our y times the a. So our -8 times the 1/2, which is -4, plus k of 1 gives us -3. I have more. If you're like, seriously, like, yeah, no, I have a gazillion of these. Well, I got 2 more in my hand. Just use your words and ask when you need something. I probably have it. -1 times our 1/2 gives us -1/2 plus 1. Positive 1/2. 1. 1/2 plus 1 is 1.5. 8, 4, 5. So it should look like that. Yeah, 1.5 is fine. Like, I genuinely do not care if you put fractions or decimals. I'm looking at the graph. The only time I'm looking at your table is if we need a partial credit for something.
Wait, how is it 1.5 is 1 times 1.5 plus 1?
1 times 1/2 gives us what? 0.5 plus 1. There we go. Okay. So plot them up. 2, -3, 1, 1/2, 0, 1, -1, 1.5, and -2, 5. So we had a reflection over the y-axis. It flipped that way. You had a vertical compression, and it shifted up 1, looking at our transformations. Yes, you see it?
Oh yeah, you called me in the middle of my crisis. You called me like 10 minutes after.
All right. We got 5 minutes. Let's do one more. One more. One more. And it's almost identical. It's real similar. It's another cubic. We still have 1s and 1/2s and minus signs. It's the same parent function. So it's the same parent table. Yeah. There you go. Okay. So what's our A value this time? What's our B? What's our H? There's no H. And what's our K? -1. Okay. Same process. Same process. Y times A plus K and X times B plus H. So we're going to take our -2 times 1/2, giving us -1. Now we're into the one that I was trying to start next last time. -1 times our B of 1/2 gives us -1/2. Again, if you want to put it as a decimal, that's totally fine. It genuinely does not matter to me. 0 times 1/2 is 0. 1 times 1/2 is 1/2. And 2 times 1/2 is 1. Y times A is plus K. So -8 times -1 gives us +8.
7?
-1 is 7. Yep. -1 times -1 is +1. -1. 0 times -1 is 0. And then we -1 to get down to -1. You're just taking them both steps. 1 times -1, -1, -2, and 8 times -1, -1, -9. So our graph is going to look like -1, +7, -1/2, 0, 0, -1, 1/2, -2, and 1, -9. So So we are super duper duper horizontally compressed. Okay? We'll work more with these tomorrow. So there's homework 3-5. So you get grumpy if I don't put it up there. Also, tomorrow you might want to have something that involves internet with you, like your phone or your computer or something, because I'm not actually going to be here. But there's already a video posted, so. But there's videos posted. Well, the IU courses all have a training. So if you're in a bunch of dual credit, we're all going to Bloomington.
I'll keep it in my bag. I was there when we walked last week.